Hello AP Chemistry students, this is your Unit 5 Lesson 2 summer homework video, and this is all over gas laws. This is going to be a quick one. So we've already talked about Avogadro's law in the last one, so let's talk about it again. So if you have two different gases that have the same temperature, volume, and pressure, they're also going to have the same number of molecules. So let's look at this. So if we have 22.4 liters of helium, nitrogen, and methane gas, all at the same pressures, all at the same temperatures, the masses of the gas are going to be different because the molar masses of those elements are going to be different in compounds, but look at the number of molecules. And so that's going to tell us that we're going to have the same number of moles of gas. So let's talk about Graham's law of diffusion. So gases move from high to low concentrations, and the lighter gases are going to diffuse faster. We've talked about this in the past. You should be familiar with this. If something is lighter, it's going to move faster. Think about a race car versus a semi-truck. Race cars are going to move faster. So the rate of diffusion, if you look at the equation, okay, so is going to be the rate of A over the rate of B is equal to the square root of the molar mass of gas B over the molar mass of gas A. So another way of saying this is that there's an inverse relationship between rate and the molar mass. So the diffusion rate and the molar mass are inversely related. So if we look at Graham's law of diffusion, when we look at this picture, you have wet cotton with NH ammonia on the left, and you have cotton that has HCl on the right. And if you were to let the gases diffuse, okay, HCl is a higher molar mass. It is about 36, and ammonia's molar mass is about 17. So obviously the lighter gas ammonia, the NH3, is going to move faster than the HCl. So let's talk about Dalton's laws of partial pressures. So obviously the total pressure in a system is going to be equal to the pressure of each individual gas that's combined. So if we were to mix the helium and argon gas in these two tanks and we wanted to know what total pressure it was, well, the helium gas is at 2 atmospheres, the argon gas is at 4 atmospheres. So to get the total pressure for that system, if we were to combine those two gas tubes, you would have the 2 plus the 4, which would be 6 total.